Okay, I think we've got most of the people here now. So we are going to start. I'll quickly give you an overview of what we've done until now. And then we start with this next concept, which is finding perpendicular distance between a point and a line. Okay, Assalamu alaikum, everyone. Let's begin then. So today, this is the next concept that we're doing. This is the last major concept that we have left in vectors. What we've done until now, in the last class in particular, is this vector equation of a line. R equals a plus lambda t. How do you write vector equation of a line? You need two things for it. You need one point and the direction vector. These are two things that you need to be able to write down equation of a straight line, right? We discussed this. We talked about what lambda and r mean here as well. Did some examples on this. Then we covered how to find angles between two lines. In order to find angles between two lines for which you have equations, you will just find the angles between their direction vectors. If you have to figure out if two lines are perpendicular, then you just check if their direction vectors are perpendicular using their dot product, and that will give you whether the lines are perpendicular or not. And similarly for parallel vectors, just have to check if the direction vectors are parallel or not. That's what we discussed. Then we talked about how to find points of intersection of two lines. We said in 3 dimensions, if you have two lines, they can either be parallel or they can be intersecting or they can be skew. We have these 3 possibilities. In 2 dimensions, we only used to have 2 possibilities, parallel or intersecting, but now we have a third possibility in 3 dimensions. And that is that the lines are neither parallel nor intersecting. This case is known as skew lines. Okay. Then we did a couple of examples on this, how to find the point of intersection of two lines and also how to prove that two lines intersect, right? That was the process that we learned. And also how to figure out if two lines are skew, how to show that. In order to show that two lines are skew, you have to show that they are not parallel and also that they are not intersecting. You have to basically prove both of those things. Okay, so this is what we have done until now, and as far as equations of lines are concerned. Now, this is one major concept that we still have to do: finding perpendicular distance between a point and a line. And this is mostly the most confusing part that you have in vectors. A question that most people get wrong. It's not that complicated once you understand it, because the questions that you get on it, they're very repetitive. You have the same kind of question in almost every paper. So once you understand the method, you kind of have to remember each step. You have to memorize each step in this process. Otherwise, you'll not be able to do it in the exam. So yes, you have to understand how it works. First of all, we'll try to do that today. But then eventually, you will kind of have to remember each step in the process so that you can do it easily in the exam, because it's a very repetitive question. Almost the same thing is asked in every question that asks you to find perpendicular distance or foot of the perpendicular. It's the exact same process that you have to follow every single time. Okay, so let's talk about this now. Distance between a point and a line. Now, before we can do this, we need to know how to find distance between 2 points, first of all. Distance between 2 points. So let's say in 3 dimensions, you have 2 points, and what you want to do is you want to find the distance between those 2 points. How can we do this? Let's say we have 2 points and we have their position vectors. There's a point OP that has position vector, let's say -1, 2, and 4. There's another point OQ. That point has position vector 7, 3, 5. These are 2 points that we have. What we want to do is we want to find the distance between these 2 points, P and Q. How can we do that? We can find the vector PQ, right? What is that going to be? OQ minus OP. Position vector of the second point minus the position vector of the first point. That's how we find the vector PQ. Now, once we have this vector, what we can do is we can find the magnitude of this vector. Okay, so OQ minus OP, what would that be? 7 minus 1, that becomes 7 plus 1, which is 8. And then 3 minus 2 is 1. 5 minus 4 is also 1. This is the vector PQ. And now if you want the magnitude of this vector, all you have to do is use this formula, x squared plus y squared plus z squared, find the square root of that. What do you get from that? 8 squared plus 1 squared plus 1 squared, square root of that. And that gives you square root of 66. That is the distance between the points P and Q. Okay, so if you had to find distance between 2 points, this is the process that you follow for that. Find that vector that connects those 2 points and then find the magnitude of that vector. Okay, so distance between 2 points is fairly straightforward. Now, graphically, it would look something like this. You have this point P, you have this point Q somewhere, and you have origin somewhere. The vectors that you're given are these vectors, OP vector, this one, and you have OQ vector. These are the vectors that you're given. Using these two vectors, what you do is, you first of all find the vector PQ. So you find this vector, and then you find the magnitude of this vector. That gives you the distance between those 2 points. Okay. Now, once we understand how to find distance between 2 points, let's extend this to figure out how we can find distance between a point and a line now. Okay, so that's the more complicated part. Distance between a point and a line. Now, whenever we talk about distance between a point and a line, we always talk about perpendicular distance. Okay, so let me specify here. We're talking about perpendicular distance between a point and line. Because otherwise, if we don't specify that, if we have a point here and we have a line here, then we could say distance between the point and the line is this, right? All of these could be possible distances. Whenever we talk about distance between point and line, we always talk about the shortest distance, okay? And the shortest distance is always the perpendicular distance between that point and the line. So that's what we're interested in. We're interested in finding the perpendicular distance between the point and the line. Okay. Now, in order to understand this concept, what we do is we will use an example from the worksheet where they ask us something like this. Vectors worksheet. Let's take an example from here. Okay, this is question number 22 from the worksheet. I'm just going to do the first part of it. Just a reminder, I think I mentioned in one of the earlier classes as well, the worksheet has some questions that involve planes, right? So equation of a plane or angle between a line and a plane. You don't have to do those questions. Planes are not part of our syllabus anymore. They used to be part of the syllabus before 2020, but now planes are not part of the syllabus. So if you see any question part that talks about a plane, you can skip that part because that's not part of the syllabus anymore. Okay, so planes are not part of syllabus. So that's why in the assigned questions, you would not see any that involves planes. And when you're practicing yourself as well, if there's any specific part of any question that talks about planes, you can skip that part. Okay, so that's why we're just focusing on the first part of this question for now. Question number 22 from the worksheet, the first part. It says, find the perpendicular distance from the point P to the line L such that we have the coordinates of the point P and the equation of the line L. Okay. So we have the coordinates of the point P and equation of the line L. These are two things that we have. Okay, now how is this process going to work? Let's try to understand it. First of all, we've got this point. We have the coordinates given. We can write the position vector of that point. It will look like this, OP. That will be -1, 4, and 11. Okay. Now make sure that you understand this process well. If you have any questions, make sure to ask those questions, because then you just have to replicate exactly the same thing on a number of questions, because as I said earlier, you just have you get questions almost identical to this. This just change something slightly, and then the rest of it is exactly the same. So we have this point, and we have equation of a line. They're calling this line L. So it's a situation that looks something like this, that we have this line L somewhere, okay, and there's a point P. Let me draw it slightly like this. Let's say the point P is here. And we are interested in finding the distance from that point P to the line L, this perpendicular distance from P to L. Okay, that's what we're looking for. This highlighted distance. Okay. Now we already know how to find distance between 2 points. If we have the 2 points given, we can find that vector and find its magnitude. In this example, in this case, if we can somehow find this particular point, let's call this point X, where P is making a perpendicular with the line L, then it will be a simpler problem that we would just have to find distance between point P and point X, and that we already know how to do, right? Px vector, if we have that, we can just find its magnitude, and that will give us the perpendicular distance. So the problem is, how do we find this point X where you have this perpendicular, right? That's the main problem. How do you find this point X on the line where P is making a perpendicular? Now there's a name, there's a name that you have for this particular point, and the questions often refer to this name as well. You should know this. This point is known as the foot of the perpendicular. Foot of the perpendicular from the point P to the point L. Okay, this is the foot of the perpendicular. So if we can find the foot of the perpendicular somehow, we can find the distance between these 2 points then. Okay, now how do you find the foot of the perpendicular? Now for this, you need to understand how equations of lines work. This is the equation of this line L, right? Let me write that equation down here. Line L has this equation, R equals 1, 3 minus 4 plus lambda 2, 1, 3. Now I spent a lot of time explaining what equation of line represents, because now we need to use that understanding. Remember, we talked about this, that this equation should represent every single point on this line L, right? That's the purpose of the equation, that it should represent every single point on this line that you have. All right. Let me write that down here just for your notes so you remember this. This equation represents position vector of every single point on the line L. Okay, it represents every single point in the line L, the position vector of that. What's the difference? The value of lambda. So if you input one value of lambda, you'll get 1 point. If you input another value of lambda, you get another point. And for some value of lambda, you would get x as well, right? But every single point on the line is represented by this equation. Okay. Now, x is also a point on this line. X is also a point on this line, right? Now, every single point in the line is represented by this equation. X is also a point on the line. So what should be the position vector of x then? We can say that is the same as the equation of the line. If we write this in simplified form, that will become 1 plus 2 lambda, 3 plus lambda, minus 4 plus 3 lambda, that is the position vector of the point X, right? We just don't know what the value of lambda is going to be. As of now, we don't know what the value of lambda is. And that's true for every single point on this line. If there was another point here, let's say that's Y, that would also have the same form. If there was another point Z here, that would also have the same form. Since X is also on the line, we say the position vector of X, OX, looks like this. And now we need to find the value of lambda that would give us this point X. Okay. Now, let me stop here. Let me pause here. Let me know if there's any confusion until this point. Do all of you understand why the position vector of X should be this? Why OX should be this? Does everyone get this? You can react in some way or write in the chat box because this is very important. Yes, Arshaman?
Sir, could you repeat how we found out the direction vector of the line L?
It's given. We are not finding anything. It's given. The equation of the line is given.
Sir, what's the question number?
It's question number 22 from the worksheet.
Okay, sir, thank you.
Okay. Equation of the line is given already, okay? So we have the point given and we have the equation of the line given. And we want to find the distance between the point and the line, okay? Since this is the equation of the line, this represents every single point on the line. X is also a point on the line. So the position vector of X should also be of this form, right? So position vector of X is coming from the equation of the line. Make sense to everyone? All right. Okay, good. So now that we know that the position vector of X is this, we have a perpendicular here. There's a perpendicular at the point X. Okay, there's a perpendicular at the point X. What do we know about perpendicular vectors? We know that their dot product should be 0. Now, which vectors are perpendicular? The vector Px, this vector, Px, in yellow that you see here, and the line L, these are perpendicular to each other. Now, dot product is used for vectors, right? We can find vector Px somehow. Right now we have OX, remember? We don't have Px yet, we have OX. So origin will be somewhere, it might be here. We have the position vector of X like this. We want to find Px first of all, because Px vector should be perpendicular to the line, okay? And that is what we can use to find the value of lambda. How can we find the vector Px now? What is Px going to be? Px is equal to OX minus OP, right? Now, we know OX already. We have written that above. 1 plus 2 lambda, 3 plus lambda, minus 4 plus 3 lambda. This is OX. We subtract from this OP, that's given in the question, minus 1, 4, 11. Let's write that here. Minus 1, 4, 11. The vector Px turns out to be this. 1 plus 2 lambda minus 1, that becomes 1 plus 1, which is 2 plus 2 lambda. 3 minus 4, that is minus 1. So we have minus 1 plus lambda. Minus 4 minus 11, that is minus 15 plus 3 lambda. This is the vector Px. Okay, this is the vector Px. So we found this vector Px now. Px vector should be perpendicular to the line L, right? Now for line L, we have its direction vector. We have its equation. For line L, we have the equation. Dot product is not used on equations. It's actually used on vectors. So what we do is we use the direction vector of the line, because when we talk about perpendicular lines, parallel lines, remember we only used to care about the direction vector, right? Because that is what is telling us in which direction the line is going. So what we do now is, in order to find the value of lambda, we say, since the vector Px is perpendicular to the line L, the vector px should be perpendicular to the direction vector of line L. Now, if these two are perpendicular, what does that mean? If two vectors are perpendicular, their dot product must be 0. So that's what we do now. We say vector px, that's this yellow vector, and the direction vector of the line L, their dot product should be 0. So px dot the direction vector of L, this should equal 0. Okay. Now let's input these vectors here. Px vector is 2 plus 2 lambda minus 1 plus lambda minus 15 plus 3 lambda dot direction vector of line L. This is the line L that we were given. What's the direction vector in this line? It's 2, 1, 3. Let's use that here. 2, 1, 3. This should equal 0. Now we just solve this equation and that will give us the value of lambda. Let's solve this. How do you find dot product? 2 plus 2 lambda times 2 plus minus 1 plus lambda times 1 plus minus 15 plus 3 lambda times 3. This should equal 0. Let's simplify this. This gives us 4 plus 4 lambda minus 1 plus lambda minus 45 plus 9 lambda. Be very careful in this calculation. A lot of careless errors happen at this particular step. So make sure that you have your signs right, plus minus, and you're doing the multiplication right. 4 plus 1 plus 9, that gives us 14 lambda. And then 4 minus 1 is 3. 3 minus 45 is minus 42. That equals 0. And we get lambda equals 3. When the value of lambda is 3, we would get this point x. And that is what we were looking for. We have found the value of lambda. Now, the rest is going to be fairly straightforward after this. But let me repeat what we have done here first. So we found the position vector of OX, right? All of you understood that earlier, right? Then we said PX vector has to be perpendicular to the direction vector of the line L. So what we did was, we said if they are perpendicular, their dot product has to be 0. So we found the vector PX first of all, OX minus OP. Once we got that vector, we said the dot product of this vector PX and the direction vector of the line L, this should equal 0. We found the value of lambda for this. This is the value of lambda that gives us this point x. So now we've got that point x. Now, what are we looking for? Perpendicular distance from P to L. That's what we were looking for. We already have the vector px in terms of lambda, right? This was the vector px in terms of lambda. This is the px vector. If we just put the value of lambda in this and find its magnitude, that will give us that perpendicular distance. Let's do that now. Perpendicular distance. That's what we are looking for. Let's find that. We have the px vector. We found that to be 2 plus 2 lambda minus 1 plus lambda and minus 15 plus 3 lambda. This was the vector px. Now we found the value of lambda that gives us that point x. So what we do is we say, let's input lambda equal to 3 here. If you input lambda equal to 3, that gives us px equal to 2 plus 2 times 3 minus 1 plus 3 and minus 15 plus 3 times 3. You can write this directly as well if you want after simplifying, and that's perfectly okay. This simplifies to 8, 2, and minus 6. That is the vector px that we're getting. Okay. Once we have the vector px, what we can do now is we can find its magnitude. Px magnitude, that gives us square root of 8 squared plus 2 squared plus 6 squared. 64 plus 4 plus 36, that will be 104. Square root of 104, that's the perpendicular distance between this point and the line. And that's what we were looking for. Okay. Now that's one thing that we can find here. Sometimes instead of finding the perpendicular distance, they ask you for the foot of the perpendicular. They will ask you for the position vector of the foot of the perpendicular. That's what they sometimes ask for. Position vector of the foot of the perpendicular. What's the foot of the perpendicular? That's the point X. So we want the position vector of X. That's OX. We also wrote that above at some point. That was 1 plus 2 lambda, 3 plus lambda, minus 4 plus 3 lambda. You can use that. 1 plus 2 lambda, 3 plus lambda, and minus 4 plus 3 lambda. That was the vector OX that we wrote above. Okay. Now you just input value of lambda in this now. Lambda equals 3. Let's put that. And that will give you OX equal to 1 plus 2 times 3, 3 plus 3 minus 4 plus 3 times 3. And you get the position vector of X, which is 7, 6, and 5. That is the foot of the perpendicular, position vector of the foot of the perpendicular. That's the other thing that you could find if you were asked about that. They did not ask for the foot of the perpendicular in this particular question, but the rest of the process is exactly the same in that as well. Only at the end, instead of using px, you use ox and then input the value of lambda in that, and you can find the foot of the perpendicular like this. Okay, so that's how this process works for both these types of questions. You can find the perpendicular distance between a point and a line, and you can find foot of the perpendicular using this same method. Any problems with this? Any questions on this? Does this make sense to everyone? Any questions on any of these steps? Okay, so I hope that makes sense to everyone. This is the summary of what we have done there. I'll just copy it there. You have to remember these steps now. In the exam, it's very difficult to think of this whole logic yourself. You need to memorize the steps in this process. This is one thing that I actually recommend memorizing. Generally, I don't recommend rote learning a lot of things, but this is one thing that if you do not remember the steps for, it will be hard to figure out in the exam itself. So remember each step in the process. What's the first thing you do? If x is the foot of the perpendicular, you first of all write the position vector of x in terms of lambda using the equation of the line L. So whatever is the equation of the line L, we say that is the position vector of x, because x is the point on the line and the line represents every single point on the line. Equation represents every single point on the line. OX vector will be the same as the equation of the line L. That's the first thing we do. Once you have done that, once you have the vector OX, then you find the vector PX using OX minus OP. That's the second thing you do. Once you have PX as well, then you say the dot product of PX and the direction vector of line L, that should be 0. And that will give you the value of lambda. Okay. And then if you put that value of lambda in px and find its magnitude, that will give you the perpendicular distance. If you put that value in ox vector, that will give you the position vector of the foot of the perpendicular. Okay, so that's the process. You need to remember the steps in this process. Do 4 or 5 questions and you'll kind of remember what to do in such problems. Okay, so that was the last concept that we had left. This is how you would approach such problems. No questions on this? Okay, good. Now, you can let me know if there are any particular questions from the worksheet that you want me to do, because in terms of concepts, we're done with everything that we need to know. We could do a couple on perpendicular distance as well, if you want me to do them. Or apart from this, if you have more questions, please let me know, because today is the last session that we're spending on vectors. We have around 45 minutes more that we can spend on doing any questions that you have from the worksheet or from any recent papers that you found difficult. We will discuss them. Okay, because in the next class, then we want to start our next topic, which is logs. Okay, so on Thursday, which is tomorrow, we are starting logs, and we should be done with that by Friday as well. We have an extra class on Friday, by the way. We have an extra class on Friday. So we'll have 4 this week. I want to get done with logs this week as well. Okay, so tomorrow and Friday, we should be able to complete logs and linear law. So we have two more classes this week, Thursday and Friday. All right, let's have a look at this question. Question number 20 from the worksheet. You're saying part 2 of this. You want me to do this first? Okay, let's start with this. Question number 20 from the worksheet. Those of you who have any other questions, you can let me know about them as well. Let's start with this one. This looks like a good question. Question number 20. Part 2 of this. Okay. It says, with respect to the origin O, the position vectors of 2 points A and B are given by OA and OB. The point P lies on the line through A and B, and AP is equal to lambda AB. Okay, so AP vector is lambda times AB vector. Show that OP equals this. Okay, so point P lies on the line through A and B. Now, point P lies on the line AB. What does that mean? It should satisfy the equation of the line. So first of all, what we can do is we can find the equation of the line AB. Let's find the equation of the line AB and see what that looks like. We have vector OA, that is I plus 2j plus 2k. And we have vector OB, that is 3i plus 4j. Now, what we can do is we can find the equation of the line. How can we do that? Let's find the direction vector. First of all, AB vector. What's that? What is AB vector going to be? Yes, Ibrahim, that's going to work as well. That's also correct. You could also do that, yes. Okay, so let me do it using both methods. So one idea is we find the equation of line through A and B. What's the vector AB, first of all? It'll be OB minus OA, right? 3 minus 1, what's that? That's 2. 4 minus 2, that's also 2. And then 0 minus 2, that's minus 2k. That's the vector AB. Now, what's the equation of the line AB? It'll look like this. R equals A plus lambda times the direction vector. Okay. Now, if we use this point, because they have 1, 2, and 2 here, so that's the first point here. If we use this point, we can write down the equation like this. It's going to be the point. So let me write down the standard form. First of all, A plus lambda D. What's the point? This is the point. This is one point that we could use. This would be I plus 2j plus 2k plus lambda into direction vector, which is 2i plus 2j minus 2k. And now if you simplify this and rearrange this, you get that same form that they have given there. So this simplified will become I plus 2j plus 2k plus 2 lambda I plus 2 lambda j minus 2 lambda k. What's the I component? It's 1 plus 2 lambda. J component, 2 and 2 lambda. So that's 2 plus 2 lambda. And the k component, 2 minus 2 lambda. That's the k component. That's the equation of the line that we're getting. And since the point P lies on this line, the point P lies on the line, that means it should satisfy the equation of the line. So OP is also going to be of the same form. It will be 1 plus 2 lambda times I plus 2 plus 2 lambda times J plus 2 minus 2K plus 2 minus 2 lambda times K. This is one way of thinking about this, that you find the equation of the line AB, and since the point P lies on the line AB, its position vector is also going to be the same. Okay, you can see that's the same thing that they have asked you to show here. That's one idea. Okay, so another way to think about the same thing could be using this relation that they've given in the question. They have told you that AP vector is equal to lambda times AB vector. Okay, let's write that down here. AP vector is equal to lambda times AB vector. Now, what are we looking for? We are looking for OP, right? We want to find OP vector. AP can be written as OP minus OA. We can do that, right? And then AB can be written as OB minus OA. Now we want OP as the subject, right? Let's keep OP on the left side and take everything else to the right side, and you have OA equal to, OA plus lambda times OB minus OA. Let me just put that there. OB is 3I plus 4J. Subtract from that OA. That will become minus I minus 2J minus 2K. OA is I plus 2J plus 2K. Let's simplify this further. Lambda times 2I plus 2J minus 2K. Now, when we expand this, we get I plus 2J plus 2K plus 2 lambda I plus 2 lambda J minus 2 lambda K. Again, take I common to see what the coefficient of I is. That's 1 plus 2 lambda times I, right? These are the two I terms, this and this. And then 2J plus 2 lambda J. What does that become? That becomes 2 plus 2 lambda times J. And then the K terms, they are 2K and minus 2 lambda K. If you take K common from them, that leaves you with 2 minus 2 lambda times K. And that's the position vector of the point P that we were looking for. That's another way of looking at the same thing. Is that all right? The first part? Okay. Let's look at the second part now. Now, in the second part, they say, by equating expressions for cos AOP and cos BOP in terms of lambda, find the value of lambda for which OP bisects the angle AOP. Okay. Now, first of all, let's follow instructions. What are they asking for? They're saying find cos of AOP and cos of BOP. Okay. Let's do that. Cos of AOP and BOP. Now, what's the formula that we have for angles in vectors? There's only one formula. Cos theta equals A dot B divided by modulus of A into modulus of B. Right? That's the only formula that we have for angles in vectors. Now, there are two things that we need. Cos of AOP. They're saying equate this to cos of BOP. These should be equal. Okay. And the reason for that is they've explained that there. Find the value of lambda for which OP bisects the angle AOB. So think about it. If you have a point O here and a point A here and maybe a point B here, P lies on the line AB. P lies on the line AB. right? Now, you have OA here like this, you've got OB here like this. They are saying, find the value of lambda for which OP bisects the angle AOB. What's the angle AOB? This is the angle AOB. OP should bisect this angle. So where should P be? It should be somewhere around here, so that when you draw this line, this angle and this angle, they are both the same. So this angle is being bisected. The angle AOP, this complete angle, AOB, this is divided into two parts by that line OP. Now, since it's being bisected, what that means is AOP angle and BOP angle, these two angles, they should be the same if the angle is being bisected. That is why they are asking you to equate expressions for cos AOP and cos BOP. Now, they have helped you here by giving you this hint that this is what you have to do. They could also just not give you any hint here, and they could have just asked you to find the value of lambda for which OP bisects the angle AOB. They could just say this as well. It was possible, right? And then you would have to think yourself that if OP is bisecting AOB, that means that this angle and this angle, they should be equal. And you would yourself have to think of equating these two expressions, right? In this question, they've made it easy for you. They've explicitly told you that this is what you need to do. You just need to equate these two expressions. So that's what we do. We equate these two expressions. Now, how can we find cos of AOP and cos of BOP? At what point is the angle? Angle is at the point O. That means the vectors that you use, they should either both start from O or both end at O, right? That's the condition. If we use vectors that both start at O, we can say for the first one, in the numerator, we would have the dot product of OA and OB. And in the denominator, we would have their magnitudes, OA and OB. For BOP, in the numerator, we could have the dot product of OB and OP, right? Both vectors starting from O. And in the denominator, we could have the magnitudes of OB and OB. This is what we want to do. Okay, now let's evaluate the dot products and the magnitudes and just input them in this equation then. Okay, let's find all of these things that we're looking for now, the dot product and the magnitudes. Do we have these vectors OA, OB, and OP? Let me write that here. OA vector was I plus 2j. Let me just write them in column vector form to save some space. 1, 2, 2, right? That's the vector OA. OB is 3, 4, 0. OB is 3, 4, 0. And OP, that is this thing. 1 plus 2, 2 plus 2, 2 minus 2. Okay. 1 plus 2 lambda, 2 plus 2 lambda, 2 minus 2 lambda. That's the vector OP. Okay. Let's evaluate the dot product OA dot OB. What would that be? OA dot OB. 1 into 1 plus 2 lambda plus 2 into 2 plus 2 lambda. We're just multiplying corresponding components and adding them. And then finally, we have 2 into 2 minus 2 lambda. Let's simplify everything, and that gives us 1 plus 2 lambda plus 4 lambda plus 4 minus 4 lambda. Now, 4 lambda and 4 lambda, they get cancelled, and we are left with 9 plus 2 lambda. Okay? Look out for any careless errors, if there are any. Then the second thing we have to do is OB dot OB. Yes, Ibrahim, that's a good point. We'll do that. Let's get to that first. OB and OP. Let's find this dot product. That will be 3 times 1 plus 2 lambda plus 4 times 2 plus 2 lambda and plus 0 because the z component is 0 there. Let's simplify this now. This gives us 3 plus 6 lambda plus 8 lambda, and that simplifies to 14 lambda plus 11. Okay, so we've got the dot products. These are going to be the numerators in this equation. Then we need the magnitudes. OA magnitude. What's that? That is square root of 1 squared plus 2 squared plus 2 squared, and that gives us 9. Square root of which is 3. Okay, and then what about OB? OB magnitude is 3 squared plus 4 squared plus 0 squared. Square root of which is going to give us 5. That's the magnitude of OB. Now, what about OP? Now, this is going to be more complicated because we have square of this plus square of this plus square of this and then square root on that whole thing. But think about it. We don't need to do all that because we have OP here. We have OP here. They will cancel each other out. Their magnitude, right, that represent distances. So we can say this OP and this OP, they kind of can get cancelled out because we can multiply this OP on the left side, for instance, and OP and OP will get cancelled. So we don't even need to evaluate that. We can just cancel it out like that. And now just input the results. OA dot OP, what was that? That was 9 plus 2 lambda divided by the magnitude of OA, which was 3. That should equal 14 lambda plus 11 divided by 5. Let's cross multiply, and that gives us 45 plus 10 lambda equals 42 lambda plus 33. And we get 32 lambda equal to 12 from this. And lambda equals 12 over 32, which is 6 over 16, which is 3 over 8. So the value of lambda turns out to be 3 over 8. That's what we're getting here. Yeah, and that's what you wanted. The value of lambda, 3 over 8. That's our final result. Okay. OP magnitudes can be cancelled out, but we cannot cancel out OP and OP. The vectors OP, they cannot be cancelled out. That would be wrong because these are vectors that are multiplying. Vector multiplication is not like normal multiplication where you have numbers multiplying. You cannot do anything with this unless you first evaluate the dot product, right? You first have to evaluate the result of that dot product, and then you can do anything after that. Okay, so this whole thing is one single term. This whole thing also is one single expression, okay? You cannot cancel anything out from this. Magnitudes are just numbers. Numbers can be cancelled out like that. We cannot cancel out vectors when we have multiplication going on like this. We first have to evaluate the dot product, and then we can do anything after that. Okay. All right, I'll do that. We cannot cancel out OP vector here. We can only cancel out the magnitude. Okay. Any questions on this? No? Let's move on to the next one now. Now it says when lambda has this value, verify that AP ratio PB is the same as OA ratio OB. Now, are we talking about vectors here, or are we talking about lengths here? Remember, I told you in the beginning, the very first session on vectors, that when they talk about vectors, they will always have these arrow signs on top, right? When they don't have the arrow signs on top, they're talking about lengths rather than vectors. So we have these lengths that we're talking about. Okay, now let me write that down here. They're saying when lambda has this value, AP ratio PB, you have to verify, it's not given, you have to verify that it is equal to OA ratio OB. OA ratio OB, we need to verify that these two are equal to each other. Okay, now how can we do this? Do we have the lengths for OA and OB already? We found them here. They were 3 and 5, right? So we already know that this is supposed to be 3:5. What about AP and PB? How do you figure this out? Do we have any information given in the question that we could use? AP ratio PB? We were given this, right? That the vector AP is equal to lambda times AB. That's what we were given in the question. Now, if the vectors have this relation, their magnitudes would also have the same relation. AP would equal lambda AB. Okay. Now think about what the situation looks like. The question says the point P lies on the line through A and B. So the point P lies on that line AB. It has to be on that line. So if this is what the ratio looks like, let's draw that line. Let's say we have a line like this. We have A here, we have B here. Lambda we found to be 3/8. So we can say this ratio therefore becomes AP equal to 3/8 times AB. So if we have A here and we have B here, where is P going to be? Let's write it down, write it like this first, AP over AB. That is 3/8. What does that mean? If distance of A from P is 3, then the distance of A from B is 8. That's the ratio. So if this whole thing is 8, A to P should be 3. So where should that point P be? It might be somewhere here, such that this distance is 3 and this distance is 5, using that ratio. Okay. So what do we understand from this? If AB over AB is 3/8, then that means that AP over PB, therefore, it has to be 3 to 5. And that's the same thing as OA over OB. It's the same ratio as that. That's the verification that the ratios are the same. So you'll have to use this ratio that is given in the question between AP and AB and use that to figure out that this ratio has to be 3 to 5. Where does 5 come from? It's 8 minus 3. Okay. Make sense? Any questions on this? Okay. Does anyone have any other questions from the worksheet? Otherwise, I'll choose a couple myself, which I think will be some good questions to practice. If you don't have any to ask. No one has any questions? Basically, what that means is that you have not practiced enough. Because if you had done that, you would have at least some questions. Okay, then what we'll do is we'll have a look at question number 11 from the worksheet. Question number 11. This is one question that I'll do that. And then from a recent paper, I have another question that is a good one that covers some important concepts as well. Let's do this one first, and then we'll do one from a recent paper. And that should be it. But these are two very good questions now. Question number 11 from the worksheet. Let's try this. These ratio questions, they are sometimes a bit tricky. Let's see how to deal with them. Okay, Ibrahim, I'll have a look at that at the end. Okay, please remind me at the end to discuss that as well. Question 30. Let's start with this one for now. Question number 11. With respect to the origin O, the points A, B, and C, they have position vectors given by this, this, and this. The midpoint of AB is M. The point N lies on AC between A and C and is such that AN is equal to N. 2 times NC, find a vector equation of the line MN. Now, how do you find equation of a straight line in vectors? We need two things for that. We need a point on the line, and we also need the direction vector, right? Those are two things that we need. One point on the line and a direction vector. Okay. Now, MN is the line that we're looking for. We need either the point M or the point N. In fact, both, because only then we can find the direction vector. The direction vector would be MN, right? So for that, we need both the vectors M and N. How do you find M and N now? Let's think about that. It becomes easier to understand if you sketch a rough diagram for this. So let's say you have a point A here, just mark random points because it's three dimensions. You cannot really draw it accurately in 2D. So just mark some random points to try to understand the situation. Let's say you have this point A here, you have a point B somewhere else, and you have a point C somewhere else. You have their position vectors given. The midpoint of AB is M. So if we were to draw a line like this, the midpoint of this line, that is point M. Now there's origin somewhere as well. Let's mark that. Let's say this is origin. The point N lies on AC. Okay, the point N lies on AC. If we were to join A and C. On this line, there's a point N now. And it's such that AN equals 2 times NC. Now, make sure that you understand this ratio well. AN equals 2 times NC. You can write it like this. AN over NC, that equals 2. Or you can say that's 2 over 1. So that means if AN is equal to 2, NC is equal to 1. So where is this point N going to be on this line? Is it going to be closer to A or closer to C? Its distance from A is 2 units. If the distance from C is 1 unit, it has to be far away from A as compared to C. So we can mark that point here, let's say. Let's say this is point N, such that this distance is 2 to 1 like this. Okay, that's the ratio between these distances. That's what the situation looks like. Now, what we want to do is we want to find the vector Mn. Okay, that's what we're looking for. We want the vector Mn. How can you find the vector Mn? We want the equation of the line Mn. For that, we need the vectors OM and ON. That's what you want. Position vector of the point M and the position vector of the point N. These are two things that we want. Let's start with OM first of all. OM. We have to start from O and reach the point M. We can go from O to A and then from A to M, right? That's one idea. So we can say that's OA. We go from O to A plus AM. Now OA is given, but AM is not. AM is basically half of AB, right? If this complete vector is AB, AM is just half of that because M is the midpoint. And that will give us the position vector of the point M now, because now we can say OA plus half into OB minus OA. That's the position vector of the point M. Now we just input values. OA is I minus K. OB is 3I plus 2J minus 3K. Subtract from this OA, that becomes minus I plus K. Let's simplify this. I minus K plus 1 over 2 into 3I minus I, that's 2I, and then plus 2J minus 2K. Let's simplify this. This gives you I minus K plus I plus J minus K, and you get 2I plus J minus 2K at the end. This is the vector OM. That's one vector that we were looking for. Okay. This is one way of finding this point OM. There's another idea as well, but in that case, you need to remember a formula. Remember how we find midpoint in coordinate geometry? x1 plus x2 over 2, y1 plus y2 over 2, right? That's what we used to do there in coordinate geometry for finding midpoints. x1 plus x2 over 2, y1 plus y2 over 2. Since M is the midpoint of AB, we could do something similar here as well for finding M, which would make this much shorter. And that would be something like this. For that, you need to remember this general formula for the midpoint in case of vectors. OM vector, that would be equal to half times OA plus OB. You could do this directly as well. Okay. So it's very similar to that coordinate geometry formula. In fact, it's exactly the same. Each component, you basically, for each component of A and each component of B, you add them together and then divide them by 2. Right? Just like we use in the midpoint, do in the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. We could find that point M like this directly as well. So how would that work here? It becomes 1 over 2 into OA, that is I minus K, plus OB, which is 3I plus 2J minus 2K. Simplify that, and that gives you 1 over 2 into 4I plus 2J minus 3K. Am I missing something? 3I plus 2J. Okay, that was minus 3K. So this becomes minus 4K, and then divided by 2, we get 2I plus J minus 2K. That's the same vector that we got using that other method as well. You can do whichever of them you prefer. For midpoints, it's generally much quicker if we use this formula directly. Okay. All right, so we have the point M now, the position vector of the point M. What about the point N? Position vector of N, that is also what we need to find out now. For that as well, we could use 2 different methods. I'll tell you about both of them. Let's start with ON first of all. ON. So we need to start from O and end at N. We can use this diagram for that first of all. That's one idea. How do we go from O to N? We can go from O to A first of all. So we can say ON vector is equal to OA plus AN. Right, that's one idea that we could use here. Now, what is AN? If this total length is 3 units, how much is AN out of that? It's 2 units. So it's 2 out of 3 of AC. So you can say AN can be written as 2 over 3 times AC. Now this does require some thinking, right? Using ratios. If AN is 2 units and the whole thing is 3 units, you can say AN is 2 over 3 times AC. Okay. And now, since you know OA and OC. You can write this as OA vector plus 2 over 3 times OC minus OA. And that will give you the result. OA is I minus K. Let's input that here. Plus 2 over 3 times OC minus OA. OC is 4I minus 3J plus 2K. Subtract from that OA, which is minus I plus K. Now you simplify this and see what that gives you. I minus K plus 2 over 3 times 3I minus 3J plus 3K, which simplifies to I minus K plus 2I minus 2J plus 2K. And we finally get 3I minus 2J plus K. That's the vector ON. That's one way of finding the vector ON. Okay, that's one idea that you could use. Okay. The other idea could be, without the diagram, using this ratio that is given. They have given you that AN equals 2 times NC. We could use that AN is 2 times NC. Now, this is for magnitudes, right? Because there's no vector sign there. But since we know N lies on the line AC, their directions are also the same, right? AN and NC have the same directions. If the magnitudes have this relation, the vectors should also have the same relation. So we could use it to find the vector ON using this ratio as well, using this equation as well. We can say AN vector should equal 2 times NC vector. Okay. And now we can write this as ON minus OA on the left side. On the right side, we have OC minus ON. Okay, now let's simplify everything. ON minus OA, that equals 2OC minus 2ON. Let's bring ON to one side, and that gives you 3ON equals 2OC plus OA. And then ON vector is equal to 1 over 3, or you can say, 1 over 3 times 2OC plus OA. And now you just have to input values here in place of OC and OA, and you get the vector ON. Requires much less thinking. You just have to input values, do some algebra, and you get the vector directly. That's another way of thinking about this. 2 times OC. OC is given to be 4 minus 3 and 2. So that's 4 minus 3 and 2 plus OA, that was I minus K. Simplify this and see what you get. 1 over 3 times 8I minus 6J plus 4K plus I minus K. And that gives you 1 over 3 times 9I minus 6J plus 3K, which simplifies to 3I minus 2J plus K. And that's exactly what we got there as well. This is another idea of thinking about that same thing. Again, you can choose whichever of them you prefer. Both of these methods will work every single time. So whichever of them you prefer, you can use that. The first one requires a bit more thinking because you have to think of the diagram and the ratios. The second one just requires some algebra, and you can just find the vector ON like that as well. Okay. Now that we have the position vectors of M and N, writing down the equation of Mn is fairly straightforward after that. We can do that. OM vector is given and ON is also given. We can find OM minus ON or the other way around. It doesn't really matter. If we find the vector Bn, Mn, that would be ON minus ON. That's the direction vector. This will become 3I minus 2J plus K. Subtract from that 2I plus J minus 2K. Right? And this gives you I minus 3J minus K. Okay, that's the vector Mn. You have the direction vector and you have 2 points. You can use any of them in the equation. You just have to write down the equation of Mn now. How do you write equation of a straight line in vector form? It's a plus lambda d, right? That's the standard form for the equation of a line in vector form. R equals a plus lambda d. A could be any one of these 2 points. It could be OM or ON, doesn't matter. If we use ON, that gives us 3i minus 2j plus k plus lambda times I minus 3j minus k. That's the equation of the line that we were looking for. You can write this in IJK form. That's preferred because in the question they have used IJK form. So in your final result as well, it's better to use IJK form. Or you could write it in column vector form as well. That's also going to be acceptable. You could also write this as 3 minus 2, 1 plus lambda times 1 minus 3 and minus 1. That's the equation of the line that we were looking for. And that's the final result from the first part. Fairly tricky, required a lot of working. The second part is fairly straightforward after that, because now that you have the equation of the line MN, you can find the equation of the line BC and find their point of intersection. We have done that before, how to find points of intersection. Once you have those two equations, you solve them simultaneously. Find the values of lambda and mu from two equations, put them in the other equation to verify that the lines intersect, and then you can just put that value of lambda or mu back in the equation to get that position vector, right? For finding point of intersection, the second part is just that standard method. Okay. Any questions on this? Because I just want to do one more question, one last question from recent paper, and that's a good one. It has a slightly different concept. I'll just do that quickly then, if there are no problems in this. No questions? Okay, good. Okay, let's do one last question then. One last question on vectors. Then we start logs in the next class, inshallah. Okay, let me just copy this question. Okay, so this is from a recent paper. This is June 2023, paper 3.3, question number 9. Let's try this one. The lines L and M have these equations. Relative to the origin O, the position vector of the point P is this. Given that L is perpendicular to M and that P lies on L, find the values of the constants A, B, and C. Now, what do we understand from the statement? We have the position vector of the point P given. That's one piece of information. And we have equations of two lines. L is perpendicular to M. The two lines are perpendicular. That's one piece of information. The two lines are perpendicular. What does that mean? If two lines are perpendicular, the dot product of their direction vectors, that should equal 0. Okay, that's one thing. Let's use that first, and then we'll look at the rest of it. Since L is perpendicular to M, the dot product of their direction vectors, it has to be 0. What are the direction vectors? If they write them in the column vector form, C minus 2 and 4 dot 2 minus 3 and 1. This should equal 0. Let's simplify this. We get 2C plus 6 plus 4 equals 0. 2C equals minus 10. The value of C, therefore, is negative 5. That's one thing that we were looking for. We have found the value of the constant C. Okay. Now it says P lies on L. What does that mean? P lies on L. The point P lies on this line L. If P lies on that line, that means it should satisfy its equation. right? If we input the point P in that equation should be satisfied. Now, let me write that equation down here first. That equation is R equals A3B plus lambda times C. We now know the value of C, which is -5, -2, and 4. That's the equation. If P lies on the line L, if we were to input the point P in place of R, this equation should be satisfied. So let's do that. Let's put P in place of R, the position vector of P that is 4, 7, and -2. It should satisfy this equation. On the right side, we have A minus 5 lambda, 3 minus 2 lambda, B plus 4 lambda. Now, since the point does lie on the line, we know that the values of lambda that we get from each one of these equations, they should be the same. So we can solve these simultaneous equations now. We can say 4 should equal A minus 5 lambda. That's one equation that we have. 7 should equal 3 minus 2 lambda. And -2 should equal B plus 4 lambda. From the middle equation, we can find the value of lambda. 2 lambda equals -4 and lambda equals -2. Put that value of lambda in these two equations. 4 equals A minus 5 times -2, and that gives us A equal to -6. And then from the second equation, from the third equation, we have -2 equals B plus 4 times -2. And that will give us B equal to 8 minus 2, which is 6. So the value of B is 6, and the value of A is -6, and C is -5. That's what we were looking for in the first part. So if a point lies on a line, that means it should satisfy the equation of the line. You put that position vector in place of R, and the equation should be satisfied. That means the X component should be equal, the Y component should be equal, and the Z component should be equal on both sides of the equation. All right, so we have the values of A, B, and C from here. That's the first part. Let's look at the next one now. Now it says the perpendicular from P, that's the last part now. The perpendicular from P meets line M at Q. The point R lies on PQ extended with PQ ratio QR 2:3. Find the position vector of R. Okay, now that's a lot to take in. I would never recommend doing this question in the middle of the paper. The second part, you should probably leave it for the end of the paper. Otherwise, you spend too much time here, and that might make you lose marks on another potentially easier question. This is only question number 9. That means most likely we'll have 2 questions after this in the exam as well. At least 1, maybe 2. You should probably do those questions first if they are easier than this, because this is fairly complicated, right? So now, first of all, let's try to understand what they're saying. The perpendicular from P, so there's a point P that we were told about in the first part. That perpendicular meets the line M. So let's draw line M somewhere. Let's say this is line M. This perpendicular meets this line at some point, and they're calling this point Q. Okay, so Q is the foot of the perpendicular coming to the line from the point P. The point R lies on PQ extended. What does that mean? If I were to extend PQ, let's extend PQ. R lies on this extended line such that PQ ratio QR is 2:3. What do we understand from that? If PQ is 2, then QR should be 3. That means this point should be somewhere around here. This is R. Such that this distance is 3 units. Make sense? We need to find the position vector of the point R. Now, it's an extension of that perpendicular distance and foot of the perpendicular method that we learned. Because in order to find the point R, we first will need to find the point Q. And what's Q? Q is the foot of the perpendicular from P to the line M. Right? So we first need to find the point Q somehow. How do you find the point Q? We use that standard process that we learned at the start of today's class. Find the foot of the perpendicular. How do you find the foot of the perpendicular? Let's follow that same process. We have the point P. Let's write that down. The point P has these coordinates 4, 7, minus 2. The position vector is going to be 4, 7, minus 2 like this. This is the point P, position vector of that. We have the equation of the line M. What's that? That equation is R equals line M, the second line, 1, 2, 3 plus mu times 2 minus 3, 1. Okay, 2 minus 3, 1. That's the equation of the line M. Point Q lies
Sir,
on
minus 3, 1. You did 3 minus 1.
Okay, sorry. Thank you for pointing that out. That should save us some time. Otherwise, we would only figure it out at the end. 2, 3 minus 1. 2. Okay, I'm sorry. I wrote that same thing again. So it's 2 minus 3, 1. Right? Okay, so that's actually something that happens a lot. So when I check exams, when you copy something from one page to the next page, you have to be very careful with what you're writing there, because these kinds of mistakes happen a lot. When you're turning the page, you kind of forget the exact thing, to make sure that you're copying the right thing. So this was 2 minus 3, 1. I wrote that as 2, 3 minus 1 by mistake, and that would have made me lose at least 3 marks in this question. I might have gotten 3 method marks somehow, but at least 3 marks would be lost because of that one single error. Okay. Now, this is the equation of the line M. Point Q lies on the line M. That means the point Q should have position vector that is of the same form. Let's write that down. OQ should be 1 plus 2 mu, 2 minus 3 mu, and 3 plus mu. That should be the vector OQ. Okay. Now we can say PQ vector should be perpendicular to the direction vector of the line M. Right? We have a 90 degrees angle here. We use that dot product thing now. We say, let's find PQ vector first of all now. We have OQ right now. Okay, OQ is not perpendicular to line M. PQ is perpendicular. So first of all, we have to find vector PQ now. PQ vector. What's that? OQ minus OP. Okay, what do we get from that? OQ minus OP, 1 plus 2 lambda minus 4. 1 minus 4 is minus 3. So that's minus 3 plus 2 mu. 2 minus 7, that is minus 5. So minus 5 minus 3 mu. 3 minus minus 2, that's 3 plus 2, which is 5 plus mu. Okay, so that's OQ minus OP, which is PQ, right? We found the vector PQ now. Now we say, since PQ is perpendicular to the line M, the dot product of the vector PQ and the direction vector of the line M, this should equal 0 because they're both perpendicular. Okay. So PQ vector, what's that? Minus 3 plus 2 times mu, minus 5 minus 3 times mu, and 5 plus mu. Dot product of this with the direction vector of the line M. What's that? That's 2 minus 3, 1. That's the direction vector of line M. 2 minus 3, 1. This should equal 0. And that should give us the value of mu that we're looking for. Let's do the multiplication. Minus 3 plus 2 mu times 2 plus minus 5 minus 3 mu times minus 3 plus 5 plus mu times 1. And that equals 0. This gives us minus 6 plus 4 times mu plus 15 plus 9 times mu plus 5 plus mu, that equals 0. And we get 14 mu plus 14 equals 0. The value of mu turns out to be -1. Right? Yeah. So mu turns out to be -1. Now, if mu is -1, do we know what OQ is now? This was OQ. Let's just input mu equal to -1 in that. Let me copy that from there. OQ vector, that was 1 plus 2 mu, 2 minus 3 mu, and 3 plus mu. Let's input mu equal to -1, and the vector OQ therefore becomes 1 minus 2, which is -1, 2 minus 3, that is 2 plus 3, which is 5, and 3 minus 1, that is 2. That's the vector OQ. So we found the foot of the perpendicular, this vector here, OQ. That should get you at least 4 marks until this point. Finding the foot of the perpendicular. Now you have to use that to find R somehow. How can we do that? We can use this ratio now. It says PQ ratio QR is 2:3. Okay. Now this is something that can actually be done mentally as well. Let me do it directly first, and then I'll show you a formal method of doing that as well if you want to write that down. One way to think about this is that you find PQ. PQ already is there. Okay, actually that's going to take some time as well, because we will need the vector PQ first of all, and then we would have to find that. Okay, no, it could actually work quicker. Yeah. All right, so let's try to do it directly first. If you understand that, that's great, because that will save you some time. Think about it. We have the vector OP. OP vector is 4, 7, -2. And then we have vector OQ. OQ vector is -1, 5, and 2. And what we want is OR vector. Now, what's the ratio? The ratio is whatever is the number of units you're going from in order to go from P to Q. If that is 2, then you should be going 3 more to reach point R. Okay. That's the ratio. Or in other words, 2:3 is the same thing as saying, this was 2:3, right? That's the same thing as saying, if this was 1, this should be 1.5, right? 2:3, that's the same thing as 1:1.5. Now you can use that to write OR directly. How would that be? How do you go from 4 to -1? How do you go from 4 to -1? You have to subtract 5, right? In order to go from 4 to -1, you subtract 5 times 1.5. That means 7.5 more to get the x component of R. What would that be? -1 minus 7.5. This would be -8.5. Okay. Similarly, how do you go from 7 to 5? You have to subtract 2 units. In order to go from 5 to the y component here, you subtract -2 times 1.5. That means -3 units. 5 minus 3, that will be 2. And then how do you go from -2 to 2? You have to add 4. You add 1.5 times that. That means +6 to get this. 2 plus 6, that will be 8. OR vector should be this, -8.5, 2, and 8. Okay. Now, if you understand that, that's great. You can write it directly. But I understand it's a bit confusing. Where did 1.5 come from? The ratio. We were given that if PQ is 2 units, then QR is 3 units. So the ratio of, so whatever is the number of units that you are taking to go from P to Q, Q to R should be 1.5 times that, because that's the ratio, right? 2:3 means 1:1.5. Okay. Okay, while I did this, I actually realized it's not that easy to understand. If you understand it, that's great. You can do it directly like this. But an easier way of thinking about this could be, which might take a bit longer, but that's okay. We use this ratio. What's the ratio that we're given? PQ ratio QR, that is equal to PQ ratio QR, that is equal to 2:3. Okay, that's what we are given. We can find the vector PQ. Do we have that anywhere here? Yeah, this is the vector PQ. Do we have Q as well? OQ we have found already, and OR we can find them. Yeah. So this is the ratio that we're given. If we rearrange this or write this in fraction form, we can say this is the same thing as saying PQ over QR, that is equal to 2/3. Or that's the same thing as saying 3 times PQ is equal to 2 times QR. Now, if that's the ratio between their magnitudes and they all lie on the same line, that means their directions are also the same, right? Their directions are also the same. If they have the same direction, that means the vectors should also be the same. So if that's the ratio between their lengths, then the ratios between their vectors is also going to be the same. 3 times PQ vector should be equal to 2 times QR vector. Now, what's PQ? We already have that here. We can evaluate that. Let me do that here on the side. PQ vector. -3 plus 2 times -1. Input mu equal to -1 there. -5 minus 3 times -1 and 5 -1. And PQ vector turns out to be -5, -2, and 4. That's the vector PQ. Okay. So now we've got 3 times PQ, which is -5, -2, and 4. Okay. -5, -2, and +4. Yeah. That's PQ. That equals 2 times QR. We can say QR is the same thing as saying OR minus OQ. OQ you know already. So it'll become, so let's take 2 to the other side. It becomes 3/2 times -5 -2, 4 equals OR minus OQ. What's OQ? This is OQ. -152. And now you can make OR the subject, and that will give you the result. OR equals 3/2 times -5 -2, 4 plus -1, 5, and 2. You can put this on your calculator one by one, and that will give you the vector OR. -5 into 3/2, that's -7.5, -1, that will give you -8.5. -2 into 1.5, that's -3 plus 5, that will give you 2. 4 into 1.5, that is 6. 6 plus 2, that is going to give you 8. That's the vector OR. That could be another way of thinking about that same thing. Substitution, what do you mean by substitution, Ibrahim?
Sir, like if we do PQ over QR, that would be equal to 2/3, right? So
Yeah.
they are parallel, right? They are in the
Yes.
same line. So we could do PQ vector is equals to 2/3 multiplied by the QR vector, and then we can like substitute OP and OQ like we used to do to solve it.
Yeah, so that's
So we
exactly what
can-
we're doing here as well. You could probably make it a bit more simple. Yeah, so that's exactly the same thing. But you're saying you first of all rearrange this to make OR the subject, and then you input this, right? Is that what you're saying? So you're saying, so do something
Yeah,
like this, basically.
yeah.
So let me do it that way as well. So you're basically saying we could write this as 3 times OQ minus OP, if we don't want to use this as well, and just input everything at the very end. This could be another way as well, like we did for the last question. 2 times OR minus OQ. And now we make OR the subject first of all. So how would that become? 3OQ minus 3OP equals 2OR minus 2OQ. And then 2OR, that becomes equal to 5OQ minus 3OP. Now you can do the substitution if you want at this point, and then divide by 2 at the very end. So you have 2OR. Substitute that here. What's OQ? OQ was minus 152. Subtract from that 3 times OP, which was 47 minus 2. Simplify this. See what that gives you. Minus 5 minus 12. That is going to be minus 17. 25 minus 21. That's 4. 10 minus 10 plus 6, which is 16, equals 2 times OR. Divide by 2 on the other side. So you have 1 over 2 times this, and OR turns out to be minus 8.5, 2, and 8. So essentially, you make OR the subject first, and then you input values rather than inputting them in the beginning. Is that what you were saying?
Yes, sir, exactly.
Okay, so that could be another way of doing this. But you see, that was fairly tricky. Finding the foot of the perpendicular, that was the standard thing. But then using that, you had to find the position vector of the point R as well. Now, make sure to do a lot of practice. In the recent papers, you will find some more slightly tricky questions. But now that you've had this practice, hopefully you'll be able to figure them out as well. Now, on Thursday, which is tomorrow, we start logs. We will cover most of the concepts for logs tomorrow, inshallah, and then linear law on Friday. So next week, and we can start next week. We can start with trigonometry as well. Then, all right. So that's it for today. I'll see you again tomorrow, 7 p.m. Around about that time, inshallah. Allah Hafiz. If you have any quick questions, you can let me know. Otherwise, we will end this here. Any quick questions, anyone? No? All right, good. Okay, Allah Hafiz.